to jump into it. So let's get started with our agenda for today. So here are the three main areas where we're going to take everyone through. So we're going to take a look at ML and AIOps. We're going to define them for everyone. What are they? How do they apply to IT operations teams today? We're going to take some time to sort of tie those back to major challenges for IT operations teams. And we're going to get into some specifics about where machine learning can really help and try to separate some of the myths from the realities of what machine learning capabilities really are. And then finally, we're going to kind of wrap up by reviewing some recommended considerations that we've seen as best practices for some of the enterprises we've worked with, and they've shared some of their experience in evaluating and selecting AIOps tools and machine learning powered tools, and we've condensed those down to some top recommendations, and we think they could be valuable to everyone here. So with that, let's jump right into it. We're going to start by digging into kind of the basics of machine learning, and this kind of sets the stage for everyone to have a solid understanding of how ML concepts can be applied to ITOps, and that definitely help us as we dig into AIOps as a category. So let's just context set a little bit. The two high-level terms that I'm sure we get bombarded with 10 times a day these days are artificial intelligence and machine learning. So let's clarify what the difference is real quick. So artificial intelligence is the broadest term. It's been around for decades as a research topic in computer science. And just to boil it down, we can say that it is allowing computers to perform tasks that would normally require human intelligence. And in simple terms, that's really our goal. And so artificial intelligence is really the destination. And for decades and decades, we've had different approaches of trying to reach that goal. And right now, machine learning is one of the hottest ways to achieve artificial intelligence. And so we can say that machine learning is one approach to AI that uses patterns in data to learn, in quotes there, intelligent behaviors without explicitly being programmed. And that phrase, without explicitly being programmed, is really the key one that can really translate into some huge opportunities to transform how we do IT operations today. So we're definitely going to unpack that further. So let's also put AIOps on the map, just so we can kind of conceptually differentiate it from AI and ML in general. So like we said, ML is one approach to AI. We've been hearing about it so much in the past 5 or 10 years because of the explosion of big data, and with the dramatic changes in access to cheap compute through cloud computing and other trends. We can now achieve things through machine learning that really weren't possible just 20 years ago. And so AIOps as a term is something that Gartner came up with, was a new label for this category of tools that took machine learning capabilities and applied them to the IT operations space. And all of us who are living in IT operations day in and day out, I think we know that we are inundated with data, and it's not surprising that the same kind of innovations that people are finding they can achieve by applying ML to other domains can also yield really amazing transformative results by applying ML to the data that we are immersed in the IT operations realm. And so AIOps is Gartner's term for that new category of tools and capabilities. And we're going to try to kind of demystify what the difference is between ML and AIOps, and sort of give you some pointers in trying to navigate the new marketing terminology that is popping up around the category. So let's just kind of quickly define AIOps a little further. Some of the confusion originally was, what does it even mean? What does it stand for? And so when Gartner first came out with the term, it stood for algorithmic IT operations. And now, because that was a little unintuitive, they have updated it to artificial intelligence for ITOps, which is, I think, what people would guess it means if they just encountered the term initially. And very specifically, they see the domains where you have big data, where you have opportunities to apply machine learning to ITOps, kind of breaking down into three main categories. So monitoring, dealing with alert data, metrics data is an obvious one. Service desk operations, ITSM operations is another big opportunity to apply ML, and then automation in general, which can mean a lot of different things, but they see that as the third major domain or subdomain of IT operations where we can achieve interesting results by applying ML. And so altogether, they see those working synergistically, and they consider that the goal of AIOps is being able to pull those together and use machine learning with the big data from all three to achieve better outcomes for businesses. But the common thread here is machine learning. So we thought it would be useful to just kind of arm you guys with some concepts that may be new to a few of you. If some of you made it through a week or two of the Coursera course on machine learning, you probably run into these. But it's good to really know at a little more nuts and bolts level how machine learning works and what's happening with the data that you're feeding into these solutions. So the first thing we would recommend you guys think about is two different types of machine learning algorithms. So supervised algorithms are going to take the raw data that you're inputting, and then they're also going to have a set of training labels or examples that provide the algorithm with an illustration of how you correctly interpret that data and create correct outputs. And so a couple examples of supervised algorithms. One is classification. You could think of an example where you feed an algorithm an image and you ask it, is this a cat or a dog? And if you give it 1 million examples of cat images and dog images, it can learn the features of the image and create a model that correctly infers whether it's a cat or a dog. Another example is as a prediction model that could say, based on the weather for the past 90 days, what is the temperature going to be like tomorrow? So both examples of supervised learning. The other major category of algorithms is unsupervised learning. And this works very differently because all you give the algorithm is the raw data. There is no requirement to feed in examples or training labels or training data. And in many cases, this is the more readily available type of data that enterprises have. And so thinking about whether your data fits more into a supervised or unsupervised model is one really important decision point as you're going through your evaluation process. A couple examples of applications for unsupervised include clustering, and this is grouping data points together based on some patterns that may not be obvious to human analysts. An example there might be taking 1 million news articles and grouping them by topic or by keywords that appear only in certain articles about certain things. Another example that's near and dear to us in the IT operations space is anomaly detection. And so this would be things like finding outliers in metrics, or if you're a credit card company, asking an algorithm to say, is this an unusual charge or not? Those are great applications of unsupervised learning. It's good to keep both of those in mind. So again, let's just double click on what we mean by each of those and provide a little context. So in supervised learning, you know the right answers up front for some subset of training data. And that could be thousands, tens of thousands, millions of examples. But the algorithm can't actually learn the patterns unless you give it examples of what the correct interpretation is. And so that's where the term training comes from. And the end result of that training is a model that you can then use in production. And so great approach. A lot of the examples that have made the news recently use things like deep learning and deep neural networks. Those are also examples of supervised learning. And as important and as sexy as the algorithms are, actually coming up with good training data can be just as much of a challenge to data scientists. So very, very much relevant questions for supervised learning algorithms. The other side of this is unsupervised learning. So again, with this approach, you don't need to know the correct answers up front. You feed in the raw data, you help the algorithm identify features, but you don't tell it what the correct interpretation of those features are. And instead, it looks for intrinsic mathematical patterns within the data, and it uses that to create useful insights. And so, again, examples of that would be like clustering anomaly detection, and you're relying on underlying patterns in the data to help make use of it and give the machine learning model the guidance it needs to create useful output. So you may be asking why should I care about supervised versus unsupervised? Yeah, we kind of mentioned it before, but usually you have a type of data that either has good training data naturally as a byproduct of some business process, or you don't. And understanding that upfront can really help guide you towards the correct solution more quickly. And understanding what's behind vendor offering, knowing whether it's backed by supervised or unsupervised or a combination of the two, can provide more accurate expectations of what you can get out of it. But we would argue that there's actually a different dimension that may be even more impactful, specifically for ITOps teams when they're considering ML-based tools. And that's the idea of open box versus black box approaches to machine learning. And so let's sort of explain that in a little bit more detail. So what we mean by black box is an algorithm where you put the inputs in, you get the outputs out, but the decision that it's recommending, you don't really understand how the algorithm arrived at that conclusion. And in some cases, this can have pretty serious implications. So insurance, credit card companies, definitely two industries that have made big use of AI and machine learning. They are running into more and more regulations that require them to be able to go back and explain to someone who applied for a credit card or a mortgage or an insurance coverage why an algorithm may have reached a certain decision. And so we would say that open box machine learning, by contrast, is easy to explain. And for IT operations teams, that openness has a bunch of really important properties that we think improve adoption and improve outcomes. So let's just sort of expand on those for a second. So we would say an open box approach to machine learning is explainable. So if you look at a classification result or a clustering result or an anomaly prediction result, you can go back to the model and get a clear explanation that a person can understand about why the model took the input data and reached that conclusion. Taking it even further, if you want to take that process and make changes to it so you can reinterpret it or incorporate institutional knowledge that your team may have, for IT operations teams specifically, that also can increase the level of trust and confidence that teams have in the outputs there. So that if for some reason the linear algebra is slightly off and it's producing some odd results, maybe that makes sense from a math standpoint, but if you can incorporate your team's institutional knowledge, you can improve the results substantially. And the last one we would say is previewable. I don't think that's actually a word, but the idea is that you should be able to back test the model based on historical data and actually see with a good level of confidence what kind of changes or results or recommendations it would make. And if your team has that level of confidence, again, you're going to be much more likely to actually see strong adoption. And so just sort of stated another way, we really see these three factors as being critical for ITOps teams adopting ML-based tools. You need to have model transparency. You need to have a sense of control so that they feel like They can trust the results, and you need to have a track record of producing reliable results so that as they roll things out, they are not second guessing the ML or standing up the ML, but still they're really using other tools. If you want ML to have a really transformative effect, you need to have all three of those elements in place. So with that, I'm going to switch over, and Siobhan is going to take us through a little more detail on AIOps. Siobhan?
Thanks, Chris. That was a great summary to help us understand how machine learning is. So now we've got a fundamental understanding there. And Chris also covered a brief definition of AIOps, and we'll go deeper here. But, Gartner coined this term around AIOps, artificial intelligence for IT operations. And really what it is a very broad category that covers a lot of different tools, processes that IT operations faces today and has to solve for, whether it's ITIL or otherwise. And there's solutions around incident and problem management where you're really looking to make sure you remain 24/7 available and you're really handling those mission critical business impacting issues and scenarios well. There's lots of solutions out there around analytics, being able to retrieve, analyze, and report out information around how IT operations is performing and what improvements can be made to improve how performance is measured, etc. There's a lot to be done around infrastructure management, especially, and we'll talk more about this, but with the digital transformation initiatives that all these organizations are going through in the world today, we're going from a data center on-prem, maybe a co-location type of scenario, to more cloud-oriented infrastructures, and how do we bridge the gap between multiple instantiations of these different types of environments, which then brings us into more of the capacity management question when we're looking at specific workloads. Are we right-sized on-prem? Are we looking at how and where we should be deploying these things and what capacity we need? And I think one thing to really understand when you look at the ecosystem of vendors out there and how you should be evaluating leveraging machine learning within the IT operations space is that there is a number of various vendors in this space. A few of them cover more than one of these buckets, and even fewer cover all of them. And that's something really important to take away. On the next slide, we'll really think about how AIOps can really help you solve some of the problems you have. And the construct here that you should think about is what's in my ecosystem today, right? We're coming from worlds where IT is functional and it's still, kind of operating in the ways in which we've defined in the past over the last 10, 15, 20 years. And so we have tools like our ITSM ticketing tools, and we have things like our configuration management databases, and we have things like our incident management platforms that leverage rule-based solutions to manage incident management, right? And the question is, as we think about how IT is transforming, do we have the right tools to accommodate the change that cloud represents, or that all of the work that we're doing within digital transformation, all of those changes represent? Are we thinking about maintenance when we consider that we have to be able to operate today what we had yesterday, as well as think about what we need to operate tomorrow as our business grows? And thinking through that, we're going to talk a lot about some of the challenges with today's solutions. Next slide, please. An example of machine learning and in AIOps, we're going to be focusing here around incident management and problem management. And one takeaway that I think it's really, really important to think about when you think of AIOps tools is they still have to deal with solving the problems that IT operations face. Now, Chris did a great job earlier talking about machine learning, but if you'll notice, machine learning gives us options for solutions, but it doesn't necessarily present the solution by and large itself. It really needs to be applied as a technique, as part of a product, as part of a solution to drive some change. And that's what I wanted to depict here when we think about how machine learning really helps us in IT operations. We still, especially in incident management, have to consider everything we need to do in incident management. We have to pull in alerts, we have to talk to all of the monitoring tools, we have to look at all of the IT infrastructure. All this data needs to come into the system. And whether it's real-time, historical, or a combination, the machine learning algorithm needs to have that information to analyze. And then from there, we can use machine learning to really drive the outcome of what we can do with all of this data, right? We can look at how we can be better or better understand what is the root cause of some of these scenarios, some of these issues. We can be more we can be more proactive rather than reactive in terms of identifying impact and assessing impact and severity earlier on. And we can also identify those unknown unknowns, right? When our human creativity doesn't allow us to recognize something that the data is telling us. And the key here is that we need data and we need to be able to apply machine learning. And as we look further into IT operations, one thing that we're going to come back to is how much data we have. And that's really around where the challenge is and why machine learning is relevant to IT operations today. Next slide, please. So to start that conversation around how IT is changing, let's go back to the basics here, right? In the past, IT has been very internally oriented. We've been thinking about what can we accomplish with technology? How can we reduce and control our cost structures? And really, what are the processes we need within IT in order to be the most efficient organization we need? Transition that into where the world is today and how modern IT organizations are operating, they're much more aligned with where the business is going. Instead of thinking about cost reduction, we're thinking about revenue impact. Instead of thinking about tools and processes within IT, we're thinking about the various different kind of hype cycles around information or Internet of Things. We're thinking about the consumerization of IT. We're thinking about how IT tools, technology, and processes can really be deployed everywhere in this globalized economy. So what does that translate to? Next slide, please. We think about lots and lots of change, and there's lots of change happening throughout the business, right? If you look at development organizations, hardware or software, they're employing much more of an automated process in order to be able to take software, infrastructure, etc., and codifying it so it can be much more readily deployed faster using new tools, new processes like continuous integration, continuous deployment. The terms DevOps is out there where we're really looking at streamlining how we perform operations and really tie that back to our subject matter experts cohesively. We're really looking at how we can improve our infrastructure landscape with the advent of infrastructure as a service, platform as a service, and bridging between our on-prem environments and our cloud-based environments. And so with all of this change, there's really seismic shifts happening within IT. Infrastructure is transforming, software is transforming. So the question remains, what's happening to IT and IT operations? As we'll see here in the next slide, has anything really changed? 10, 15 years ago, maybe this situation would have looked a little bit more simpler with less tools, less people, less noise. But what we see with the scale and complexity of all these different technology stacks we're adopting, at the pace at which we're adopting them, with all of the different applications and movements and initiatives within our business, we see lots more activity. And that translates into noise, a lot more tools, a lot more best of breed tools that are really specific in their function that allow us to communicate, collaborate, as well as have more visibility. We really have to wonder, how can we handle this type of scale and complexity in today's world? Can we simply throw more people at the problem? Is that reasonable? Is that practical? Next slide. So how can we move forward? How can we change the conversation or even change the outcome from that historically very segmented and siloed operation into something much more dynamic, considering that the IT landscape is also changing, whether we're thinking about cloud, whether we're thinking about different types of architectures for your application stacks or whatnot, or whether we're even thinking about different technologies around deployments. And at the same time, while we consider all that, we have to remember IT is additive. Everything we had yesterday still remains today, and we have to keep those lights on while we continue to support innovation and digital transformation across our business. And the reality here is this is where we leverage tools like automation, machine learning, all of these new capabilities that are possible today to ensure that we can handle that scale and complexity. Next slide. And this it comes back to, in the ecosystem today, do we have something that will help us with solving these problems? And if you look at specifically, again, in the incident management, problem management domain, we have these legacy stacks that use lots and lots of rules that will enable us to have that type of automation. The question is, does that work for us going forward? And just as a quick recap, how do these rule-based tools work? We have these subject matter experts who know what the processes are and how to interpret the data. They codify that process, apply it, and then continue to iterate on what the machine does with that data set to continue to identify exceptions, outliers, etc., constantly manifesting more and more rules. And over the periods of months, years, we end up with the scenario that we have thousands, tens of thousands of these rules that define how we should be operating on this data. And then we continue to see more data come into the system. Can we really understand tens of thousands of rules so we know what the codification of that next rule should be to handle the next outlier? Can we really maintain all of this kind of mess of rules going forward? Is there a simpler way with all of the data that's coming in? That's really the question we as IT operators have to deal with. And that's specifically how machine learning can help, right? When we think about IT operations and the tools out there in the environment. As data is coming into the system, we really need to focus on learning from the environment, leveraging all of the institutional knowledge to handle the known knowns, but also leverage the intelligence in the system itself to be able to handle those unknown unknowns, and do that at a point or in a process by which we can scale effectively as more and more information comes at this, as more and more of these initiatives drive more applications, more technology stacks, more things coming onto IT's plate in a cost-effective manner. Over time, we can realize even bigger and broader benefits from this machine learning and from this automation, where we can, continue to improve our 24/7 operations 365 days of the year. And central to this topic of machine learning is we need to make sure we have that control. Chris did a great job of outlining this open box versus black box methodology around machine learning, and that is going to be pivotal to ensure IT operations has that auditability, that compliance factor to understand what the machine is doing, how it's doing it, why it's doing it, so it can be held accountable for these actions over time. Next slide, please. In a real life example, let's examine how machine learning can be applied to the event management, incident management space. And this is something we at BigPanda really embrace wholeheartedly. We still see a plethora of data coming into the system, right? We leverage very robust, scalable software to be able to handle that load, to be able to process that data and apply some specific machine learning techniques to make sense of all that noise and really drive focus into the operator's hands to be able to effectively operate on top of these incidents, where we're leveraging things like pattern recognitions, different types of unsupervised machine learning techniques with different algorithms to cluster all of this related information together. And as you can see from this specific example, we're taking roughly 178, 200 alerts and driving them down into just a handful of these incidents that operators can focus on. Next slide, please. Now I'd like to shift gears, and Chris and I are going to kind of play back and forth on this, but we've covered a number of different topics, right? We talked about what is machine learning and how you should be thinking about machine learning in the space of IT operations. We've talked about the marketing and industry terms around artificial intelligence and IT operations, or AIOps. We've talked a substantial part around what's relevant in there to IT operations. But now as you guys go and evaluate different vendors who have machine learning in their tool sets or machine learning powered tools that are targeted for the IT operations space, let's cover some of the key criteria you should evaluate. And there's really three buckets of these. I'll start with the first one. Again, it comes down to your ecosystem. What do you have in your existing tool set, in your tool belt, as well as what are the different sources of data that you have today, and how well does that tool, does the vendor that you're looking at accommodate these different things, right? Can you ensure that all of your critical data sources align to the desired outcomes that the machine learning powered tool will offer you? Right? Will it ingest all of your monitoring tools? Will it connect to all of the collaboration systems you have? Will it be able to, work in a best of breed ecosystem where you cannot live without your different types of monitoring tools, be it synthetic tools, whether it be network intelligence tools, be it, different application performance tools? And with the data that you get from these tools, how can you leverage that data to train these machine learning models to give you the best outcomes for your business? A generic general purpose algorithm can only be so good. You really need it to be applied to your vertical, your industry, and your specific business environment. Can you leverage historical information versus just, real-time active live data? And finally, how important is it for you to have that control of what the machine learning engine is doing? And how much do you have the ability to audit the system so that you can remain in compliance in terms of the actions you perform, so that you can learn and improve your processes, as well as be held accountable to your business in terms of the outcomes that come out on the other side? From here, let me transition and let Chris talk about some of the evaluation criteria that he's really come up with that can drive us forward here. Chris?
Yeah, thanks, Siobhan. So the kind of next bucket of evaluation criteria we wanted to share with you were all around capabilities and time to value. This is an important one to ask your vendors as you're talking about ML solutions. You want to have some realistic expectations around when you can actually start to show an ROI, or are there opportunities for quick wins? And this is particularly important if your organization is kind of early in that adoption of ML and AI tools. I think there's a lot of healthy skepticism around what ML can actually achieve. If you are sort of championing some of these technologies, it's important for you and important for the overall adoption of a solution to actually show that this stuff really works. And so as you're discussing these things with your vendors, I would highly encourage you guys to identify those opportunities for quick wins and really prove out that the ML can do what it says it's going to do. And eliminate some of the skepticism that no doubt is lurking in the backs of the minds of a lot of your decision makers and your executive sponsors. Another critical one we would say that's kind of related to that idea of quick wins is what is the overall time to value of deploying those ML capabilities, and can you deploy it incrementally? So we would say there are some very natural ways to kind of to approach a large ML rollout in phases. And so looking at specific data sets, specific applications, specific teams, there are usually some ones that are natural outliers that would disproportionately benefit from AIOps tools or ML capabilities. And again, those could be your best choices for quick wins. Again, the more agile you can be in your approach to deploying ML, the more likely it's going to be successfully adopted and actually achieve the outcomes that you're shooting for. Another critical consideration there is who is actually responsible for developing the ML model. And this is something I think is especially important for anybody who has some data scientist resources in their organization. It's very important to know if you're going to have to pull in a bunch of your data science folks or data engineering folks to actually build models on top of the solution you're buying, or if those models are effectively baked in or fully managed by your vendor. It's important to know if you are essentially buying a toolkit that you are going to have to use to build the models that you ultimately use in production, or if those models come fully assembled. and fully managed as part of the solution. So two very, very different approaches. Your experience is going to be different. Important to know that going into an ML tool adoption scenario. Another critical one is knowing if you're using fundamentally supervised or unsupervised algorithms under the hood. As we talked about before, this can have a really significant impact on the end user experience. And so supervised models are going to be able to essentially follow examples. And the critical piece there is the input data and the training data. And unsupervised models are going to do more around organizing and separating and identifying patterns within data without necessarily having that training data. If it is a more supervised based model, very important to know upfront where that training data is coming from and how much of that training data do you need to actually start to see good value out of the ML solution. So again, once you've identified that it is a supervised model, have that discussion about where the training data comes from, and ask for realistic estimates about how much data is required to actually see good results. It's very easy for that to kind of go unspoken and then lead to some misaligned expectations down the road. And finally, important to know, are we dealing with more of an open box approach to machine learning or more of a black box approach? And again, sometimes black box is easier, but when you're dealing with something as mission critical as IT operations data, and operations folks are some of the most cautious and conservative folks in IT that I've ever encountered. It's critical that they actually have confidence in the outputs and the decisions that are coming from the machine learning. It may be a case where even if black box is easier, it's better to take an open box approach that your team will actually trust. They will has a level of transparency so they can see what's going on, and they can control it in some of the same ways that they control other parts of the IT estate today. So the last group really focuses on the idea of ROI and total cost of ownership. And so here, you would think some of these are obvious, but we've run into some projects that have gone sideways because they weren't considered early enough in the process. But are you looking at IT operations pain points and teams that are experiencing those pain points that are really well aligned to the benefits that the ML solution can deliver? And so again, the machine learning is going to be able to find patterns in large amounts of data. Are you really thinking through how those patterns and being able to process those at scale are aligned to the teams that are working through those IT processes today? In some cases, those teams may feel that introducing ML is threatening their jobs. What is that perception going to have on rollout and the effectiveness of the solution? Or are they going to have a different perception that this is helping them do their jobs more effectively, that it's a force multiplier and an enabler for them, and allows them to end up doing less busy work? And so making sure that the real benefits of ML are aligned to the pain points of your teams, and you're within the domain of what the data can actually provide for you is a really important one to hit up front. I think we covered open box versus black box. The last one we want to cover is this idea of, does achieving the ROI from machine learning actually require your teams to make major changes to their process or the tools that they're using today? And whether it's ML or AIOps or something completely different, one of the biggest challenges we have in this space are actually getting good adoption. Lots of teams make huge investments in tools, and then they actually don't see enough adoption for those tools to actually realize the returns they were expecting. And so ML and AIOps are no different in that the fewer changes in process and tools that your team has to make to actually successfully adopt, the greater the chances for overall success. And so we would highly recommend that you think about the process change and sort of effectively handicap your expectations for results based on how drastic the changes are that you're asking your team to make. And with that, I think we had just kind of one closing thought kind of along those same lines. Machine learning is not magic. We've certainly seen some cases where people were hoping artificial intelligence would solve world hunger and Mideast peace and also make them a sandwich. But in reality, it's just some pretty amazing math. We think you can see some awesome results from it. But at the end of the day, it's not going to do anything that some smart people couldn't do at scale. Where we think that it's a best practice to really find the best ways machine learning can be deployed for your teams, but it's not magical at the end of the day. So I think with that, we're going to see if there's any questions. Siobhan, did we have any questions that came in so far?
We do have a couple, and I just wanted to call out that in the control panel for the GoToWebinar, you should have an option to add a question, and we'll definitely get to it. The first question here, Chris, is maybe one thing you can start with is, we mentioned training in the conversation around machine learning algorithms. The question is, what can I expect with my tools out of the box, and how much training do I need to do?
Yeah, so that's a great question, and the answer as usual is it depends. What we have found is that with supervised algorithms, you need to provide representative examples at a large enough scale that the underlying patterns in the data really start to, the underlying models get weighted enough that you start to see the difference between sort of random responses from a model and the expected responses will get smaller and smaller over time. So it's something where real data scientists look at the F1 scores of a model, and they expect that as the training continues, the error rates will get smaller over time. In practical examples, it may mean you need thousands, tens of thousands, sometimes even hundreds of thousands of examples and training data before you start to see really good results from a model.
And just to be clear, also that's also going to require some review and potentially some kind of false starts when you think about how you deploy machine learning. So that's another consideration to have, is what to do during the training phase of this algorithm, and how do you train it, whether in production or otherwise. Is that right, Chris?
Absolutely true. And the best cases are where you have some training data as a natural byproduct of a business process. I would say in IT operations, things are unfortunately usually not that clear. Sometimes you don't know what a root cause was, or you don't know the single device that started an outage. And so it can be very challenging to even generate the training data in the first place, just because we're in a domain with so much uncertainty.
Awesome. We got another question here. And the question is, if I want to use machine learning in IT operations, you guys touched on this, we did touch on this, but to make it more clear, do I need data scientists and machine learning engineers on staff? And how does that work?
Sure. So I'll take a crack at that, and then you may have a perspective as well. So again, it really depends if you're dealing with a solution that is providing a toolkit, and the expectation is that you're going to use that toolkit to develop your own models, train them, deploy them, test them, iterate on them. In a case like that, you might need your own data science team. I would say we have seen much more success with organizations rolling out more fully managed solutions, where the models are essentially pre-trained and the algorithms don't require that kind of from the ground up development. And so it really depends on the solution, but we've seen a lot more success with approaches that don't require organizations to BYODS, bring your own data scientists.
Yeah, I think, in my opinion, I think we're talking the same thing here, and it really depends on what your organization is able to support. If you have them on staff, then we can certainly leverage that expertise. We have time for maybe one more question, and there's a series of questions here to really kind of highlight BigPanda's relevance around all of this machine learning space and IT operations. So, kind of the questions start from, is BigPanda an AIOps tool, to how does BigPanda incorporate machine learning into their correlation capabilities and the predictive nature of all of these. So maybe Chris, if you can give a quick overview of BigPanda's offering around AIOps and machine learning, I can chime in as well.
Sure thing. And I would say BigPanda in general is trying to tackle the event management and the incident management space, kind of those two working together, pulling in a lot of the different alerts and IT signals that a NOC team would normally be looking at day to day. And so we take an approach that we think is quite a departure from traditional rules-based approaches to event management and correlation, where we use very high-level patterns to inform correlation. We do very low latency pattern recognition on alerts and other sources of signals from infrastructure monitoring, system monitoring, APM tools. And we pull that all together in a way that gives operators much better situational awareness and starts to automate a lot of the routine parts of the incident management process. And so one of the key enablers for doing that effectively, we found, is using machine learning to automatically identify patterns in the event data and the alert data. And we do that in an open box approach, so that your operations team can actually review machine learning suggestions, deploy them, make sure that they're effective. And we think it's a great way to combine institutional knowledge from your teams along with the best insights from machine learning.
That was a great summary, Chris. And I would also say that in terms of how machine learning is applied in the IT operations space, it's very early days for us, not only at BigPanda but just in the industry overall. And we see lots of opportunities to continue to improve and enhance how machine learning is applied to the IT operations space. Folks, it's been a great time with you all today. We have so many questions pouring in, but unfortunately we don't have time to answer any more. So what we're going to do is we'll follow up with you all one-on-one. I do apologize that we're not able to cover them live here on the webinar. Thank you all for joining. It's been a pleasure to share with you some thoughts that we have about how machine learning is kind of taking hold in the IT operations space, and also share with you BigPanda's relevance in that space. Chris?
Yep, I enjoyed the time together, everyone. I hope it's been informative, and we'll be doing more of these soon. So thanks to everyone, and I appreciate the questions that everybody sent in.
And with that, we'll go ahead and end. Thank you once again, everybody.